We are recording.
Okay, we are going to find an area under a curve. And although we don't need a picture to answer this question, I'm going to go ahead and draw a picture just to make sure we're making sense of what this is asking. All right, so this is an exponential decay function with this negative in front of the exponent. So when x is 0, e to the 0 is 1, so the function value is 100. So the y-intercept here is 100, and then it's going to decay and eventually approach 0, but we're just going to 10 here, so not all the way to the end. All right, so there's just a rough sketch of what that function curve looks like, an exponential decay function, and we want to find the area under that curve from x equals 0 to x equals 10. So the area of this region. So you don't have to draw a picture. You can totally do this problem without the picture, but the picture is helpful and may be helpful to just think about ballpark figures, how big or small my answer should be. If I can think about something that's 100 units high and 10 units wide and think about area of that, 10 times 100 is 1,000. So if this were just a complete box here, I should end up with 1,000 for that answer. So this answer should be less than 1,000. I can also maybe think about this point here. This would be at x equals 10, and the y value would be 100 times e to the negative 0.3 times 10, so e to the negative 3. So 100 over e to the third. You could get a decimal approximation for that. That's about 5-ish. Get out your calculator and get a decimal approximation for that. And so you can also think about sort of another bound on your answer here. If I had something that was 10 units wide and only about 5 units high, this part, the area would be 50. So I know my answer should be somewhere between 50 and 1,000. Although that doesn't give me much exactness, at least it helps me with the ballpark answer, that if I get an answer that's 30, for example, I know that that's out of the realm of what sounds like a reasonable answer for this area. Okay, so area under the curve, that is the meaning of a definite integral. So we are integrating from 0 to 10 of this function. So x equals 0 to 10 tell us these limits of integration here. And then the function that we are integrating. Okay, so we're going to use fundamental theorem of calculus to find the answer for this definite integral. And so we're going back and thinking about antiderivatives. And how do I find the antiderivative of this function? All right, so the 100, we know that we can pull out front. I know the antiderivative of e to the x is just e to the x. But here I don't just have x in the exponent here. So I'm going to need to use a u substitution. So when I do a u substitution with a definite integral, there are a couple of other subtleties to be careful about when you do that. I'm going to go ahead and write my u substitution work over here, and then we'll come back over here to the integral. So the 100, I'm going to go ahead and pull out front. I'm going to need to do a u substitution. I'm going to let u equal the function that's inside the exponential function. Remember, u substitutions are about undoing chain rule. So my u is going to be negative 0.3x. I then need to find my du. I need to make sure everything matches up. So I have a negative 0.3x right here. That's going to be my u. I do not have a negative 0.3 dx. So I can go ahead and divide this coefficient off. So 1 over negative 0.3. Maybe you clean that up. We'll do it later. And that is equal to my dx. So in place of my dx, I'm going to put 1 over negative 0.3 du. And so that takes care of all the variable parts of this. So we're going to be able to do that. The other thing to be careful about, though, when you do definite integrals and u substitution, is that these are x values. And if I'm going to convert the integral to be in terms of u, I really should be converting these also to u values as well. So I need to think about when x is 0, that's the beginning limit of integration, what is u going to be? And so I'm just using my u substitution that I chose based on the function to convert these x values to u values. So u is going to be negative 0.3 times 0, which is 0. And then I also need to do that when x is 10. So u will be negative 0.3 times 10. So that's negative 3. Okay, so I'm going to also need to be able to, I'll just put a little triangle around these. Circle, box, and a triangle. All right, so I need to convert those limits of integration. Oops, don't forget the negative sign that's there. All right, so convert the limits of integration also to be u values. So all of this started out in terms of x values, but I'm going to convert it all to u values. All right, so I'm going to have the integral from u equals 0 to u equals negative 3. Be sure you put the right one in the right place. Often we have the smaller number on the bottom, but because of our u substitution, notice that we actually have the smaller number on top this time. The 100 can come out front. I'll go ahead and do that in the next step. E to the e, not u, e to the u, e to the u. And then in place of the dx, I'm going to have 1 over negative 0.3. I can pull this constant out front along with my 100 du. So 1 over negative 0.3 du went in place of the dx. Okay, so I'm going to go ahead and pull these constants out front. So I'll have 100 over negative 0.3. And you can get out your calculator and simplify that if you want. And then I'm going to have my integral from 0 to negative 3 e to the u du. Antiderivative of e to the u is e to the u. And then I need to substitute in my limits of integration. So this is where we're using our fundamental theorem of calculus that says if you find the antiderivative, then you're going to evaluate that antiderivative at each of these endpoints and subtract them. So negative 100 over 0.3 turns out to be 1,000 over 3. So I'm going to just rewrite that as 1,000 over 3 or 333.3 repeating. That's what this coefficient simplifies to be. Then I'm going to have e to the, put in the upper limit of integration first, and then minus, here I'll have minus a negative, so I'm going to make that plus 1,000 over 3 e to the 0. All right, so at that point I have an answer. It's kind of ugly a little bit. It's hard to know, like, is that number between 1,000 and 50? We said at the beginning here that the answer should be somewhere between 1,000 and 50. So maybe you get out your calculator and you get a decimal approximation for that. E to the 0 is 1. So this whole last term here could be written as 1,000 over 3. And maybe if you look at an answer like in the back of a book, or if you look at solutions sometimes in the online homework, they'll go ahead and put a positive term in the answer first. So 1,000 over 3 times e to the 0 is 1. It's just 1,000 over 3. Since that's positive, they'll sometimes put that in the front. And then minus 1,000 over 3. E to the negative 3 is 1 over e cubed. So you could write it like this if you want. Not necessary to do that. What might be more useful, though, is to get out your calculator and get a decimal approximation for this to see if your answer is between 1,000 and 50, just to make sure that your answer makes sense. So my approximated answer here is 316.7 on my calculator, which makes sense based on my estimates at the beginning. If I had made a mistake in my u substitution or the coefficients and I got an answer that was, say, 30 or 3,000, I would know that that's off because of my initial picture that I drew and just thinking through what this answer means. All right, we'll look at some more examples and some more videos.